Can you solve sine of x is equal to 2? And you might think it's impossible, because if you think about a graph of y equals sine of x, its value can only go between 1 and minus 1. So how can the output of sine of x be equal to 2? Impossible, right? Well, indeed, there's no real solutions to this equation. But if we look at imaginary and complex numbers, then actually we can solve this equation. Now, the first thing I need to introduce you to is different forms of a complex number. If, for example, we had the complex number 0 plus 1i, I is the square root of minus 1, is called the imaginary unit. This is the real part here, the 0, and this is the imaginary part. Now we can plot complex numbers on something called an Argand diagram. This is an Argand diagram where the horizontal axis is the real axis and the vertical axis is the imaginary axis. So if we had 0 plus 1i, it's 0 on the real axis and 1 on the imaginary axis. So let's plot that. I is going to be here. There's something called the argument of a complex number. And the argument is just the anti-clockwise rotation from the positive real axis. So what angle do we have to turn here? Now, with complex numbers, we always do angles with radians. So instead of 90 degrees, that's actually pi over 2 radians. So the argument of I is pi over 2. But actually, you could do a full rotation and then another pi over 2. And in total, that's 5 pi over 2 radians. So in fact, the argument could be pi over 2 plus any multiple of 2 pi, because 2 pi is a full rotation, where n is an integer. Now, if you knew this argument here, you could substitute it into this or this expression here to write this complex number in a different form. So if we wanted to write this in exponential form, the theta here is this expression here, so we could write it as e to the power of I and then the pi over 2 plus 2 pi n. And this result here is going to be really useful later on. So let's get back to solving sine of x is equal to 2. If we were to start with this equation at the top, so e to the ix is equal to cos x plus I sine x, we can see there's a sine x term here, and we're trying to solve sine of x is equal to 2. It'd be nice to get rid of this cos term here. And here's the trick. If you replace the x with minus x, so e to the minus ix, well, cos of minus x is the same as cos of x, like cos of minus 30 degrees is the same as cos of 30 degrees. But if you do sine of minus x, it's minus sine x. So we're going to get minus I sine x like that. And then if you were to subtract the two equations, we get e to the ix minus e to the minus ix is equal to 2i sine x. And then if you divide both sides of the equation by 2i, you get sine of x is equal to e to the ix minus e to the minus ix over 2i. Now we said we're solving sine of x equal to 2, so this is equal to 2. And if we just multiply both sides of that equation by 2i, we get e to the ix minus e to the minus ix is equal to 4i. So we're trying to find the value of x here to solve the original equation. Now we could write the e to the minus ix as 1 over e to the ix. And then you can see that e to the ix term is repeated. So if we were to let y is equal to e to the ix, make this substitution, we get y minus 1 over y equals 4i. And if we multiply both sides of the equation by y, we get y squared minus 1 equals 4iy. Now that looks like a quadratic equation, and we can solve quadratic equations using the quadratic formula. So we just rearrange this a bit. We get this, and then here the a is the coefficient of the y squared term, so it's 1. B is the coefficient of the y term, so it's minus 4i, and c is the constant term. And if we substitute that into the quadratic formula, we get y is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Then if we just simplify that a bit, we get 4i plus or minus. Now I squared is minus 1, so we get minus 16 plus 4, which is minus 12. And if we simplify that further, we're just going to get 2 plus or minus root 3i like that. So that is y. Now, y we said was e to the ix. So we're getting closer now. E to the ix is equal to 2 plus or minus root 3i. Now we're trying to get x on its own to solve this equation. And the way we get rid of that e is to do the natural log of both sides. So we get ix, because the natural log cancels out the e, is equal to the natural log of 2 plus or minus root 3i. Now, when we have a log of a product, so something times something, you can do log of the first thing plus log of the second thing. So we're going to get ln of 2 plus or minus root 3 plus ln I, like that. Now, earlier we had an expression for I. We said we could write it as e to the power of pi over 2 plus 2 pi n I. And for the natural log there and the e to the power of cancel each other, so we're just left with ix is equal to ln of 2 plus or minus root 3 plus pi over 2 plus 2 pi n I. And then we can divide both sides of the equation by I, and we get x is equal to ln of 2 plus or minus root 3 over I, and we just get rid of the I there, so we get pi over 2 plus 2 pi n, where n is any integer. Now we're nearly done. We've got this division by I. If we multiply top and bottom of this fraction by I, the I times I is I squared, which is minus 1, and at the top we just get I ln 2 plus or minus root 3. So the final solution to this equation is x is equal to minus I ln 2 plus or minus root 3 plus pi over 2 plus 2 pi n, where n is any integer. And that is the final answer.